to projects. In this video, we are going to discuss about the project which is securing cloud data, a machine learning based categorization approach for cloud computing. So first, let's understand what is the project about. So what is this cloud computing? Cloud computing is a modern way of managing data that shifts storage from local devices to remote servers, and these are accessible over the internet. This change brings benefits like easy data access from anywhere and simplifies sharing. However, as more people use cloud computing, there is need for improved data security as well as privacy. So these traditional systems they often rely on, that is they often apply the same level of encryption to all the data, which can be inefficient and may not adequately protect sensitive information. And moreover, accurately categorizing data based on its confidentiality level becomes challenging, and this can weaken the overall security of the system. So to overcome all these limitations, the author in the base paper he proposes to use machine learning algorithms for automatic text document classification and incorporates NLP pre-processing and feature extraction techniques. So this system categorizes data into three different classes. One is basic level, confidential level, and highly confidential level information by utilizing random forest, naive Bayes, KNN, support vector machine. So the author he has used all these four techniques to classify the data into basic, confidential, and highly confidential. So this is all according to the base paper. To boost the performance as an extension, we have integrated ensemble methods which are voting and stacking classifier, which combines predictions from various models to enhance the accuracy. So among voting classifier and stacking classifier, the stacking classifier, which combines random forest and extra tree classifier with light GBM, has shown superior performance, that is superior accuracy, and so it is chosen for the deployment. Moreover, we plan to develop a user-friendly front-end utilizing Flask framework for user testing with the robust user authentication for heightened security. So moving on to the algorithms used, I mentioned you already that we'll be using all of these algorithms, that is voting classifier, stacking classifier, support vector machine, KNN, naive Bayes, and random forest. The last four are according to the base paper, and the first two are which we have proposed. So stacking classifier performed well, so we have chosen it for deploying it in the front end. Moving on to the front end integration. To build the web application, we have used Flask and we have deployed a project. So what is this Flask? Flask is like a lightweight web framework for creating websites using Python. We used Flask in this project to make a website where people can interact with the data sensitivity classification system. And with Flask, we can set up features like sign up and sign in using a simple database called SQLite 3. So users can give messages on the website for analysis. Flask, it helps to manage all these interactions by directing them to the right parts of a project, that is backend, where messages are processed and predictions are made. So in this way, users can easily use project through a web browser. Moving on, to implement this project, we need software and hardware requirements. And the software requirements are application of Anaconda, primary language of Python, front-end framework of Flask, backend framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap. And hardware requirements are operating system of Windows, processor of 5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. So this is all about our project. Now let's execute it. To execute, we need to open the code folder which contains source code files. So open the code folder. So these are the source code files in the code folder of our project. So the first folder we have is static folder. This folder contains files related to project styling and interactivity. They include CSS, JavaScript, and Bootstrap files. Moving on, here we have templates folder. Here lies all the HTML pages which are utilized in the project. They are index.html, about.html, etc. And each HTML file represents a different page of the website and provides structure layout for displaying content to the users. Moving on to app.py file, this Python file it encompasses front-end logic of the project. It handles server-side operations, including processing user requests, interacting with the database, and dynamically generating content to be presented in HTML templates. And here we have model file, which contain the algorithm information, that is algorithms used in the project. And these files, they are loaded into the project code during runtime. And here we have two IPYNB files. One is notebook IPYNB and the other one is test IPYNB file. These are the Jupyter Notebook files which contain the codes, graphs, outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. Moving on to the next file, which is R8 test all terms file and R8 train all terms text file. In these two files, we have the data that is used in the project. So let us open it. I'm opening R8 train all terms. So this is the dataset used in the project. This dataset includes Reuters text categorization collection dataset obtained from UCI machine learning repository. The dataset comprises of various types of data such as commercials, announcements, news articles, organizational account information documents, and military information sourced from international repositories. So we'll be using this data to train all the models to classify the information as basic level, confidential level, or high confidential. So now close this. Similarly, we have in this R8 test all terms. So this is used for evaluating how well the models are performed. That is, this dataset is used for evaluating the models. Now close this. Moving on to the sample file. Here we have the test cases. That is some information. Here we have messages that will be used for classifying the information as basic level, high level, or confidential in the front end. So we'll be using all of them as test cases. So now close this. Moving to signup.db file. This file is a database file which is used to store the user information. So we understood all of the files. How will they be used in the project? Now let's execute it. So copy the path of the code folder from the address bar of the file explorers. So I'm copying the path. Now open the Anaconda prompt. Using the command cd followed by the space, paste the copied path and now click on enter. Here we can observe that current directory is changed to the code folder's path. Now compile app.py file by giving the command python space app.py and click on enter. This command will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which will be the local host and the port unless configured differently. So this is the local host and this is the port. Now copy this local link provided by the Flask framework and paste it in any web browser. So I'm copying the link. I prefer Google Chrome, so I will paste it in that. Paste the link here and click on enter. So this is the web page of the project, which is displayed in the browser, and this web page is developed using Flask framework. So first click on sign up and enter all the registration details if we are registering newly. I have already registered and I have an account in it, so I'll directly sign in. So click on sign in, provide the username and the password, and now click on login. We have logged in successfully and we are redirected to prediction page. So here we can see a text box in which we are supposed to give the message. Based on the given message, we will get the prediction that the message belongs to basic level, confidential level, or high confidential level. So let's enter the message. Now let's open the sample file in which we have the test cases. So here we have the sample file. So let's try giving the first test case. So copy it, get back to the application and paste it here. And now click on predict. Here, this is the given message. And here we got the prediction as the content type is highly confidential. Highly confidential is nothing but the data represents the most sensitive information that requires the highest level of protection. So this message has to be protected, that too in high level. Let us enter one more message. Click on home. Get back to the sample file. Let's try using the second test case. Copy it. Get back to the application. Paste it here. And now click on predict. So here we got the prediction for the given message. This is the given message. And here we got the prediction as the content type is basic class. Basic class is nothing but typically includes non-sensitive information that doesn't pose significant risk if accessed or disclosed. So it doesn't require any kind of security. And the topic for the paragraph is most dependent upon these words. Let's give some more messages. So click on home, get back to the sample file. I'm going to copy the third test case, get back to the application, click on predict. So this is the message given, and here we got the prediction as the content type is confidential. So confidential is nothing but it contains sensitive information that should be protected from unauthorized access or disclosure. So this message has to be protected from unauthorized users. And the topic for the paragraph is most dependent upon these words. Let us enter one more message, click on home, get back to the application. So we will try using the fourth test case. Click on predict. And for the given message, here we got the prediction as the content type is highly confidential. So this message belongs to highly confidential information which has to be protected. And the topic for the paragraph is most dependent upon these words. So we will give one more message, click on home, get back to the sample file. Let's try using the fifth message. Click on predict. And here we got the prediction as the content type is highly confidential. And the topic for the paragraph is most dependent upon these words. Let us enter one more message, click on home, get back to the sample file. So now we will try using the eighth message, get back to the application, give the message here, now click on predict. So this is the given message and here we got the prediction as the content type is basic class where there is no need for protection. And the topic for the paragraph is most dependent upon these words. Let us enter one more message. So we will use the ninth message, get back to the application, paste it here and now click on predict. So for the given message here, we got the prediction as the content type is highly confidential, which has to be protected. And the topic for the paragraph is most dependent upon these words. Now click on sign out. Before clicking on sign out, we will see the graphs of the project. So click on about link. So here we have the graphs. So the first graph which we have is sample outcome graph. On x-axis, we have classes and on y-axis, we have count. So in this way, just by giving the messages to the system, it will detect the information, whether it is of high level confidential information or whether it is confidential information or it is not confidential, that is basic level information. So now we will see graphs of the project. So click on about link. Here we have graphs of the project. So this is the first graph and here we have comparison graphs of the project. This is data set graph and here we have comparison graphs. So this is accuracy comparison graph where on x-axis we have accuracy scores and on y-axis we have algorithm names. And here we have precision score comparison graph. This is recall score comparison graph and this is F1 score comparison graph. So now click on sign out. The application of ensemble methods, including voting classifier and stacking classifier, has significantly improved the accuracy of data sensitivity classification in cloud computing. The stacking classifier, which combines random forest, extract tree classifier, and light GBM, emerged as the most accurate model, and it is selected for the deployment. Furthermore, the development of user-friendly front-end using Flask framework with robust user authentication features has enhanced security and usability for end users.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.